Hello friends, this is Jim the Science Doc. I'm going to do something a little different with this video here. Usually when I prepare these videos for you, I'm looking at specific papers published in peer-reviewed journals, and I basically try to disseminate or condense down the take-home points of that paper without getting too hung up in the nitty-gritty detail typically associated with scientific papers. Try to bring you to the essence of the papers. What I'm going to do with this video here is share with you basically a series of anecdotal observations. Now, anecdotal observation, of course, is not strict, hardcore science, but it helps us get a handle on what's going on. And I myself will share you personal anecdotal observations that I have been doing. And basically, what is this related to? Looking for signs of global warming? Look around you. They're all around you. So when you start hearing people saying, oh, it's just bonking, blah, 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 and it's all horse hockey, you can share some of these things with them. For example, let me start off with this one. More than 40 years ago, the University of Maryland biologists started studying when wildflowers, birds, bees, and butterflies first appeared each spring at a particular location. These days, plants and animals are arriving at Rocky Mountain Biological Lab a week or two earlier than they were 30 years ago. The robins that used to arrive in early April now show up in mid-March. Marmots end their winter slumber earlier. Going back to Maryland, the wildflowers are blooming earlier. The birds and bees are showing up earlier. There's still a timing issue, and I've done videos in the past about the timing issue that birds could miss when the insects are at their peak numbers and therefore not be able to find enough food for their chicks and so on. So there's a timing issue. It's part of nature recalibrating itself, adjusting to what's going on. The problem is basically that the changes are happening too rapidly for nature to really adjust. So they have to make big adjustments, and it is not able to because the changes are that rapid. As I've always stressed, and whenever I talk about such thing, it's the rate of change that's the key critical point. So, basically, what the contention is, if the climate were not changing, we wouldn't be seeing these kinds of rapid changes. It's hard to believe that it's been 30 years since Dr. James Hansen, the noted NASA scientist, first testified before Congress about the dangers of global warming. But yes, he has. And basically that the heat-trapping gases due to our activities is a prime driver of it. And just to note, ExxonMobil knew about this in the mid-70s, and they chose to squash it. They chose to not disseminate that information. They chose to embark on a disinformation campaign, which a lot of people these days have drunk that Kool-Aid, and now is part of the reason we hear about all these climate change deniers. ExxonMobil knew back in the 70s that CO2 levels increasing will make the planet warmer. I'm not making this up. They knew. So, if the climate is changing, guess what? Nature will change along with it. So, and that's basically the picture, if you will, that scientists who make these anecdotal observations portray. And you don't even need a thermometer, you don't need a rain gauge to notice climate change. You just observe the timing of certain things. For example, thanks to Henry David Thoreau's Walden Pond experience, he kept detailed accounts of the ongoings of nature around him, as evidenced by the blueberry bushes. Blueberry bushes are now blooming earlier than they did when Thoreau was there, and he noted the dates of that. We know about the dwindling population of polar bears in the Arctic. We know about the corals worldwide dying off. Now, there's two factors going on there. Yes, there's the warming of the surface water, but there's also the mixture of the CO2 with the water to form carbonic acid, which then is deleterious for the coral polyps and the symbiotic algae, the zooxanthellae that reside within the coral polyp, and they die off, and this is when we get the coral bleaching. Scientists have documented 28,800 cases of plants and animals responding consistently to temperature changes. And this was a study in the journal Nature that goes back to 2008. Excuse me. Nature is extremely sensitive to temperature, and nature is reacting to the warmer temperatures, said Boston University biologist Richard Premack. The dramatic change is happening right in front of us. Going back to Thoreau's blueberry plants, he charted when they first flowered. So this is in the 1850s. It would typically, on average, happen around May 16. In the past 10 years, the average is April 23. Premack started tracking blueberries there in the 2000, so he's not able at this point to specifically say how much of the earlier blooming is due to warming temperatures in the last 30 years, but he figures, a good portion of it, at least 1/3 is. In 1983, mail carrier John Latimer started keeping track of when the birds, chipmunks, and butterflies emerged, when the trees and plants bloomed, and when they changed colors and dropped leaves, and where was he? Northernmost Minnesota. He basically says, spring's coming earlier. May not be consistent, but on average it is. And so we have that bit of anecdotal evidence. Starting about 30 years ago, the growing season in general around the northern hemisphere rapidly changed to a new normal with earlier spring and later fall, said Mark Schwartz, a University of Wisconsin Milwaukee geographer. In the lower 48 states, 2012 was the earliest growing season on record until it was edged out by 2017. In the U.S., fall's first frost is happening about 9 days on average later since 30 years ago, while the last frost of spring is happening almost 4 days earlier. This is according to NOAA, National Oceanic Atmospheric Administration. So later frosts, earlier last frost indicates a longer growing season, about 2 weeks. And it's not just, this will be good, we can grow crops and so on. Well, that also allows things for like ragweed and any of those of us who suffer from hay fever. We will have 2 more weeks to enjoy sneezing. Just to illustrate that point, high ragweed days across America swelled from 1990 to 2016, according to a study by the U.S. Department of Agriculture's Louis Ziska. In Kansas City, the number of high pollen days jumped from 58 to 81. Yeehaw. Allergies and asthma are on the rise. Climate change isn't the only reason, but it definitely contributes, said Dr. Howard Frumpkin, who is a former environmental health chief at the Centers for Disease Control and Prevention, and he's now at the Wellcome Trust in London. Frumpkin said ragweed and poison ivy trigger more powerful allergic reactions with higher carbon dioxide levels. Some of the hardest hit places on Earth are underwater. I've already touched upon coral reefs. Okay. In addition to being sensitive to warmer waters, we also have the bleaching issue I just described. And the problem with the warmer waters is that you can actually get a stratification right in the upper layers of the water. And that stratification for those corals that are found in those upper few meters, that stratification may be sufficient enough to not have productivity and not have the mixing of the nutrients into those upper layers, so that primary, secondary productivity will drop off. So that's part of the problem, because I've done videos where I talked about you need a mixing event to get the nutrients in the water column, but then you need a stratification to help stabilize the water column so that productivity can proceed. The reverse of this is if you have early stratification or a permanent stratification and no mixing bringing the nutrients, that is not good. So that's part of the problem going on with coral reefs. Here's the interesting thing. I talked about the bleaching of the corals. They go white because of heat stress and also acidification. But there was no global mass bleaching of coral until 1998, 20 years ago. Another hit in 2010, and then 2014 to 2017 was the biggest global mass bleaching of them all, and it devastated the Great Barrier Reef in Australia particularly heavily. And this is a statement by Mark Eakin, who is a coordinator of NOAA, Coral Reef Watch. Melting ice has made polar bears the poster animal of climate change. Studies show that their survival rates, reproduction rates, and body weight are going down in most parts of the Arctic, said Stephen Amstrup, who is formerly with the U.S. Geological Survey, and he was the top polar bear researcher. He's now chief scientist at Polar Bear International. In parts of Alaska, Amstrup found a 40% population drop since the mid-1990s. More open water, the bears are forced to swim more. Water, because of high specific heat, can also pull out more energy out of an organism. So the bears are losing heat energy. They're using up their fat reserves much quicker, and then oftentimes they swim to an ice floe, but they can't find food. They need, frozen water. They need ice, and the seals will have their breathing hold, and the bears wait for the seals to breathe, and they pounce. Well, open water, seals can breathe anywhere, and the bears are missing that. So bears, you've probably seen the photos of basically emaciated bears. Rather distressing. When Amstrup first started studying polar bears in Alaska, he was tracking the resurgence of the animals from widespread hunting in the 1950s and 1960s. After that point, they were basically granted protection status. But starting in the late 1990s, they started losing their habitat, and we weren't seeing as many big old bears. They're dying. Ornithologist George Devoki, on his 47th summer in Cooper Island, Alaska, studying shorebirds, is another accidental climate scientist, meaning that he's there probably studying the feeding ecology or something like that, but he's, as any scientist, he's making observations of what's going on, and he's noticing a few things. In 1988, things started getting strange, Devoki said. In the years that followed, seabirds like the black guillemot started arriving earlier, laying eggs earlier, and not surviving as well. And he blames warming for that. In 1989, Devoki counted 220 pairs of birds. Last year, there were 85. 2/3 of the chicks died. He says, I was just studying birds. I don't take any pride in that I may be documenting the end of an Arctic seabird colony. Then my question is, why do the chicks die? Probably because the parents are not able to find enough fish to feed them. Why are there not enough fish? You have a changing regime in the ocean as well. For example, in in the area, the Bering Sea, Chukchi Sea, and so forth, historically, diatoms have been the dominant phytoplankton group. Diatoms, first of all, it has shells tests made of silica, but diatoms are a cold water phytoplankton. With all this warming that's going on, and remember, it takes a lot more energy to warm water than it does to warm air. There's been a documented shift in the phytoplankton regime. The diatoms are being replaced by coccolithophorids. We call them coccolithophorids because it's tongue twister. So the coccoliths are a warmer water preferring group of phytoplanktons. If you change the group of phytoplanktons, you may change the, what zooplankton can feed on them, and there you go up the food chain. And the timing of the blooms, water conditions, when does the bloom occur, and allowing for primary productivity, etc. So, the reason why the guillemot chicks are not surviving is probably insufficient food. And if you also warm up the water, this may surprise people, but fish that live in cold water want the water to be cold. But also, if you warm up the water, as the temperature of water increases, the amount of gas that can be dissolved decreases. Solubility of gas decreases with increased water temperature. So if you increase in the water temperature, the dissolved oxygen content will be dropping, and that may be sufficient to kill the fish. Kill the fish, what are the bird parents going to find? That's a very likely mechanism. Catherine Hayhoe, a climate scientist at Texas Tech, has heard non-scientists accusing the government of researchers of manipulating temperature data to show warming. This is a common thing we have to put up with. It's complete bull. There's no cooking the books. Nature is broadcasting a clear signal about climate change. There is no cooking in the book. We get often accused of, well, you guys have, an ulterior motive. You want your funding, this, that, and the other thing. Well, first of all, we're dealing with a bunch of idiots in Congress who are anti-science and definitely anti-climate change. And also, let's face it, a lot of research scientists in, science, doing this kind of work, not exactly raking in the bucks. Really, they're not. They're not making millions of dollars, let me tell you that. The average, depending where they're at, the average salary might be, and this would PhD level, might be anywhere from $60,000 to $150,000, if that. Of course, there'll be other outliers and so on and so forth, but for your typical university level research professor who has to spend a lot of time writing grants to get these yahoos in Congress to give money, which they won't, this is what goes on. So I personally am sick of hearing this, and I basically don't tolerate any more patience with that. I've been on a few these social media forums, and I've actually been reprimanded for not engaging in civil discourse. And I'm like saying, and my response was, I'm sorry, when someone says complete BS, I'm going to call them out. Plain and simple. You don't like it, tough, too bad, but that's what it is. So yeah, there's no cooking of the books. If you don't trust the thermometers, throw them out, Dr. Hayhoe says. All we have to do is just look at what's happening in nature. So, what's my personal anecdotal evidence? Okay, I live outside Fairbanks, Alaska. I live out in an area called Gulfstream Valley. I'm in a low spot. Typically, whatever the temperature is at my house, it's about 10, 15 degrees warmer in town, or at the airport where the measurements are typically made. And I used to have this running joke with a person I worked with in the math department, and he said, well, I don't see how you can live in a low, cold-lying spot. I live up in the hills. And I go, yeah, but I've got a garage. So I don't have to worry about plugging in my vehicle. It's in a nice 50 above garage. So I'd rather live in that situation. But anyway, so oftentimes I've seen some really cold temperatures. I mean, the coldest I personally ever experienced in all my years here in Alaska was 72 below. A little chilly. I was living in a tiny log cabin, and there was ice forming on the walls on the inside. It was cold. I had a tiny little wood stove. It wasn't sufficient to keep that place warm. I was barely able to keep the place at 25 degrees. Positive 25. Still, not exactly going to be taking off the coats inside. And that was about a good, almost 2 weeks of that. That was a bit nasty. So, where I'm currently living now, in the house I built, is for the last 5 winters, I've been noting the daily temperature during the winter. Over the past 5 winters, I have recorded temperatures of 40 below or colder 23 times. 17 of those days were from 5 winters ago. The past 2 winters, I have not recorded a single day where temperatures reach 40 below or colder. The past 2 winters. I got down to 36 below this past winter, but 2 winters without seeing temperatures of 40 below or colder. It used to be we would get, you get that Siberian high pressure system, it just comes sliding over, and it sets up shop over interior Alaska and the Yukon, and it's going to be 50, 55, 60 below for 2-3 weeks at a shot. You just have to wait for that high pressure system to erode, only be replaced by another high pressure system. And the joke was, ooh, it warmed up to 35 below, and everyone runs to town to do errands and stuff like that. Only in Alaska do we cheer when it warmed up to 35 below. But seriously, that's what it used to be. Now, if it gets cold, cold being 40 below or worse, 30 below, it's chilly, not cold. And by the way, there is a marked difference in the air and what it does to you from 45 to 50 below. You can actually feel it and taste it and smell it, believe it or not. But, now if we get 40 below or colder, it lasts at most 4, 5, maybe 7 days. But I said, last 2 winters, not a single day of 40 below or colder. Of course, the Arctic is where things are really changing most dramatically. So, I mean, it's great for my heating bills, but it's obviously things going on. And I'll be preparing a report on the changes in Alaska over the past 3-4 decades of what's going on. Flora and fauna moving north, the polar bear situation, temperatures, permafrost thawing, etc. So anyway, just again, you just all you have to do is just look at the timing of when things happen in nature and compare it to when they would historically occur, and we can see there are changes going on. So anyway, I want to thank you for your time. The video ran a bit longer than I anticipated, but we'll talk soon. Hello folks, this is Jim asking for your help. I want to grow this channel significantly. I want to increase the number of people who subscribe to my channel. I want to increase the number of people who are supporting patrons on Patreon for this channel. Patreon.com/Science Talk with Jim Massa. I do not receive funding of any sort from anyone. So the information I share with you is the information as found published in the peer-reviewed journals. No propaganda, no BS, just the science, and of course I give you my interpretations and analyses based on my experience as a scientist. So please tell others of the work I do here, tell others of my channel. Share my videos, post them on other social media platforms. But we need to disseminate this information to more and more people, to a wider audience. And I need your help in doing that. For those of you who are already patrons and support me on Patreon, thank you. Thank you for your support and continued support. Together we can do this. So you'll find details in the description box below how to support me on Patreon. And thank you. Thank you for your help. Thank you for your continued support. It does mean a lot to me. We can do this.